we start part C of module 5, Quicksort. So this is a very important sorting algorithm. Quicksort, from the name, you can see its performance, its efficiency, supposed to be quick in some special way. Yeah. So let's look at this special sorting algorithm. C.1, Introduction to Quicksort. Yeah. First, so let's look at why we want to study another new sorting algorithm. We have learned several sorting algorithms, but why we need to try to get a new one, right? So there must be some special reason. So the reason here is, look at the title of the topic, emphasize overall performance. Emphasize overall performance. Okay? Yeah. So what is the overall performance? What is the overall performance? Yeah. Average case, right? Yeah. I remember I gave this kind of question several times. The best way to describe overall performance is the average case efficiency. Yeah. So emphasize here, we want to find some special sorting algorithm that has the best, or hopefully near the best. Yeah, because it is very hard to argue which one has the best overall performance, right? So very hard. But we can say near the best, okay? Pretty close to the best, okay? All right. First, so let's look at the idea first. So how do we find a new sorting algorithm with very fast average case efficiency? So we use the divide and conquer approach, but in a different way. Remember, we have many different ways to use divide and conquer with different, with different focus, right? Different focus. Yeah. So here, so what is our focus? Okay. Yeah. So the goal here, it's clear. All right. Yeah. But we need a completely new way to understand that divide and conquer approach. Yeah. All right. So here, in order to get a very fast algorithm with good overall performance, we may need to sacrifice a little bit. Yeah. You have to sacrifice somewhere else. Yeah. The little part we can tolerate, slower performance, that is the poor worst case performance. So we may have some special situation, the performance is very poor. Okay? Yeah. But we must put that bad situation under control. So what kind of control? What do you mean? Put that under control. The probability for the worst case is very low. It could happen, but the probability very low. Then we take overall consideration. We can overcome that very little special situation easily. So that's the idea. Okay. All right, so let's continue our investigation. Change view on divide and conquer. We can take different views, right? Yeah. Every time when we try to develop a new sorting algorithm, we change our view on the same problem. We revisit it many, many times. Every time we use a new view on this question. Yeah. All right, so here, we just learned merge sort before, right? Yeah. Here we like to compare it with the merge sort. So I hope you can remember the merge sort a little bit. Yeah. later we will practice merge sort. We will, in our homework number 2, we need to practice the merge sort a lot. Yeah. So I hope you study the videos of the merge sort. All right, so let's do the comparison here. Yeah. In this table, 2 columns. The first one, merge sort. Second one, new idea. We want to take for this new sorting algorithm. But when we do comparison, we want to look at these 3 categories: divide, conquer, and combine. All right. First, the divide step. We know the merge sort very fast, because we chop the array right in the middle to get 2 subarrays. That's it. Yeah. So in that way, we get big theta of y, of 1 efficiency. Yeah. Then conquer recursion, right? So recursion, automatic. So we do not need to do anything on it. It is automatic. Then combine, we have to do a lot of things at the combine step. Then the cost we have to pay at the combine step, big theta of k. But here, the k means the current data size, the number of elements in the current subarray we are working on. So big theta of k. Yeah. All right. Then the new idea, we have to change a different view. We have to shift our focus, okay, in order to get a completely new algorithm. Here, the focus we shift in this way. Okay? Just the opposite. Okay? We are willing to pay more cost at the divide step. When we divide 2 subarrays, we want these 2 subarrays have very good properties. Okay, very good properties. Now, in order to get that special property, we have to pay relatively high cost. How much high? This much high. Okay, similar to that cost. So we are willing to pay that high cost, relatively high cost. All right, but we need to, pay off at the combine step, right? We need to get that payoff at the combine step. Yeah. The special property can be used at the combine step. Put 2 subarrays together. Suppose each one has been conquered by the recursion. Okay, recursion. Yeah, conquer step. Then if both subarrays are sorted, then when we combine to get a big overall sorting subarray, yeah, the whole array is sorted easily. Yeah. Is that possible? It's possible. Yeah. So in that way, the combine step, very cheap. Big theta of 1. Yeah. So that's the shifting focus. That's the way of shifting the focus. Completely different view, right? We hope this new view can result in a new fast sorting algorithm. All right? Yeah. So you can see, so that's the analysis part. Before we work on the solution, we try to understand the motivation. Why we do it in this special way. All right, so next. So we can call this new idea, that's the quicksort. Okay, so next, we need to, fix the detail. Yeah. Try to get the, solution details. How to make combine step easy, right? How can you, it's not magic. You have to justify it, right? Yeah. How to make that happen? Yeah. Let's try to get more information. Yeah. almost do nothing in the combine step. Is it possible? Yeah. Let's try to imagine the best situation we can have in this step. All right? Yeah. The first subarray, the second subarray. Okay? The divide step. So here, let's do not worry about the divide step. Okay? Just whatever way we use to divide the original array into these two subarrays. Yeah. Before conquer. Yeah. Yeah. Before conquer, before we call recursion, before conquer, before we sort it. So each one not sorted. Okay? All right. Then recursion, conquer step. Okay? Yeah. After that, each one is sorted. All right. Then let's consider the combine step. We want to make a whole sorted array from these two sorted subarrays. Yeah. But when we do it, we just put them back to back. That's it. That's all because we want to, what do you mean, almost do nothing? We do not want to change the position of any element. We just put these two subarrays back to back. Then we wish the whole array is sorted. That's the meaning of this almost do nothing. Okay? All right. But is that possible? The whole array is automatically sorted without moving any element in these two subarrays. Is that possible? You can imagine the ideal case. Under some ideal situation, it is possible, right? Yeah. Because if that could happen, there is no costly merge step. The merge step is the cheapest, as cheap as possible. Okay? All right, yeah. So we try to think about that ideal situation. Yeah. So the goal after conquer, when combine, do nothing. Yeah. Arrange two subarrays back to back, one after another, then the whole array automatically sorted. We need that. We just need that property. Okay? That's what we need. Yeah. So look at what condition. To have that property, what condition do we have? We need some special condition here, right? Yeah. The condition is before the conquer, we need some special condition. That condition here, if I put here, very simple. Okay? Any element in a subarray must be less than or equal to any element in B subarray. Yeah? B subarray. Any element in A subarray, the first subarray, must be less than or equal to any element in B subarray. That property, think about if we have that special property, can we just put two sorted subarrays back to back, one after another, to make the whole array automatically sorted? Yes, by intuition, it must be true. Yeah. But how to make that happen? That's another issue. That's the hard part of Quicksort. That is the hardest step we need to conquer in this problem. Yeah. We will see that. Yeah. Remaining of the lecture, from now on, remaining of the lecture, we will solve that problem. Okay? All right. Yeah. Okay, so that when we do the divide step, we want to have this property. That's the key property we like to have for our divide step. Okay? Yeah. All right. Next, let's investigate our most important step, divide step. If we can implement this divide step with this special property. Then we're done, right? The whole problem is solved. So you can see that is the key step. Okay, all right, yeah. So let's try to get more information for this step. Requirement: how to split the array into two subarrays, A subarray and a B subarray, such that A of I is less than or equal to B of J. So you know the meaning of that, right? Yeah, very easy. We can understand the meaning. Yeah. All right, but here, when we do that divide step, we only require this property, but for each subarray, we do not require elements sorted. Elements not sorted in general, right? But the conquer step will take care of the sorting part. Conquer step, yeah, recursion, conquer step will get each subarray sorted. So we don't worry about it. Yeah. Automatic. Yeah. So that's the good thing about recursion. Here you can see the recursion idea, although we have to pay some cost. The cost is usually not cheap, yeah, but the result is very good. So we will take it. Okay? Yeah. All right, so that's the introduction part. So starting from the next video, so we try to solve the problem, divide step, the main step. Yeah. All right, so let me finish the